These motors have lots of applications, like picking up stuff. We're going to make a crane today. From a coding perspective, our main change is that we want to run the motors at different amounts of power, and we want to only run the motors for a second or two. So we're going to start with our basic motor driver code, use the analog write function to send half of the power, 3/4 of the power, we'll even send 1/4 of the power, and full power. Since full power is 255, we will send 127, half of 255. These motors spin very quickly, and our string is pretty short. So we'll run it for 1 second as a test. In addition, we'll run it for 2.5 seconds, 2 seconds. We'll use this as a variable we can change. You could run the code just like this, but I'm going to show you how to make an if statement because I'm doing a demo and need to control this code from the laptop. I'm going to include serial in the first line, beginning the serial connection in the setup with serial.begin 9600, so that way they're communicating at the same wavelength. Together, this means that I can use the serial monitor under tools to send information and receive information from the Arduino and the laptop. In my loop, I'll write serial.read == 0, or that's the two vertical lines, serial.read == 48, then the code operating the crane. The finalized code will show that serial is capitalized every time. Let's cover that one more time. Serial allows me to send a message to the Uno. I want to operate my crane if I send it as 0. I write the if statement so it understands 0 as 0, the crane will run. If it understands as 0 using the ASCII code, then it will see my 0 as 48, and will still run the crane. I know that the ASCII code is a bit of a curveball, and there's other materials that help you understand this code later in this course. We'll go into depth in future videos, but just wanted to give a quick explanation. For now, we are truly focused on using our motors to pick up this pencil. We are operating our crane. For the first run, we'll simply tape our motors to the desktop. If you don't want to put tape on your table, you could put something heavy on the motor to keep it in place, or simply hold it on the sides. As a reminder, we are powering the Arduino Uno from the laptop. The Uno has the code we already discussed. The Arduino tells the motor driver when to send power through the out1 pin and receive it through the out2 pin. We use the ENA pin to send how much power we want to use. I start by using the analog write function in the code to send 127 out of 255 to the motor. We ran many tests. We tested it with whole power for 500 milliseconds or 0.5 seconds. We lengthened that to 1.5 seconds. Then we tried that at 2.5 seconds. Then we went down to 3/4 power, 75%, which is the number 191. And we ran that for 2.5 seconds. We went to half power, 127, and ran that for 2.5 seconds. Then we went down to 1/4 power, which is 64 out of 255 for 2.5 seconds, but the motor didn't turn. We tried at 100, and the motor didn't turn again. You can hear that it's trying to spin, but it just isn't enough power. Our final test was half power, 127 out of 255 for 2.0 seconds, 2000 milliseconds, and that's a sweet crane. Today we became crane operators. It allowed us to explore changing the amount and the duration of power sent to one motor. We modified our code and tested often. This is stuff that you can do to design your own robots. Thanks for learning with us.